Here's our first lesson on factoring. In this lesson, we'll look at the method of common factoring. Factoring a polynomial is the opposite of expanding. In past math courses, you learned that expanding means to go from a product of expressions, factored form, into just a sum of a bunch of terms, which is standard form. And we do that by multiplying the factors together. And there are different methods for multiplying factors. Depends on what we have. We would either do distributive property, or we could do FOIL if we had binomials being multiplied together. In this lesson, we're doing the opposite of expanding, which is factoring. So to expand, we had to multiply. So to factor, we're going to have to do the opposite. We're going to have to divide. We're going to have to take something that starts in standard form, which is just a sum or difference of a bunch of terms, and get it into factored form, which is a product of multiple factors. So how are we going to factor a polynomial? Well, there are lots of ways depending on what our original expression looks like. But in this lesson, we're just looking at common factoring. And to common factor a polynomial, what we do is we remove the greatest common factor as the first factor. So we look at all the terms and we see what is the biggest number and or variable that divides evenly into all of the terms in the set. We then take that greatest common factor and write it as the first factor in our expression. And then we divide each term by the greatest common factor that we took out to obtain the second factor in our expression. And then we'll have accomplished taking something that started in standard form and writing it in factored form, a product of two factors. So let's see what that looks like. Part 1, we're going to be removing monomial common factors. We're going to be removing a single term as our first factor from each of these expressions. Notice in example 1, each of the expressions is in standard form. It's just a sum or difference of a bunch of terms. We want to rewrite each of these in an equivalent way, but as a product of different factors instead of just a sum or difference of terms. So how we do that, if we look at example A, we look at both terms, negative 5x and 20, figure out what is the greatest common factor between those two terms. Well, if we think of 5 and 20, the factors of 5 are 1 and 5. The factors of 20 are 1, 2, 5, 10, and 20. The greatest common factor between 5 and 20 would be 5. And since the first term of my expression is negative, I'm going to remove a negative 5 as my first factor. So my first line, I need to make sure I start with an equal sign, because what I'm going to write here is equivalent to the line above. I'm going to remove a negative 5 as my first factor. And then in brackets, I need to divide both terms by the greatest common factor that I put out front of my expression. Notice this is equivalent to the line above because all we did was multiply the expression by negative 5 and divide it by negative 5. Negative 5 over negative 5 is 1, so it's not going to change the value of this negative 5x plus 20. It's just allowing us to rewrite it in a different way. Now, one thing we have to make sure we do to complete this question is we need to simplify our second factorial we have in brackets. Just to make sure you remember to divide both terms by the negative 5 we took out as our first factor, I'm going to rewrite in brackets the negative 5x being divided by negative 5 and the 20 being divided by negative 5. I normally wouldn't write this step, but for the first time, just to make sure you see that both terms are being divided by that greatest common factor, I'll write that step for our first attempt here. In the brackets, if we simplify both of these divisions, they'll work out nicely because we know for sure that negative 5 is going to divide evenly into both of those terms. We strategically chose that so that would happen. The first term divided by negative 5, negative 5x divided by negative 5 is 1x, and 20 divided by negative 5 is negative 4. Notice negative 5 times x minus 4 is equivalent to our original expression, negative 5x plus 20, but it's now written as a product of two factors. It's now in factored form. If you wanted to check and make sure you've done a factoring question correct, what you could do is use distributive property to expand the expression. Multiply negative 5 times both terms inside the brackets, and you should get back to the original expression. Let's try part B. If we look at both terms, I have 8x squared minus 7x. Now, if we look at the coefficients of the terms 8 and 7, the greatest common factor between 8 and 7 is just 1. But we also need to look at the variable parts of each of the terms. They both have a factor of x. The 8x squared has 2 factors of x, and the 7x just has 1 factor of x. When terms in an expression have the same variable, you're always going to common factor out the one that has the smaller exponent. So between these two terms, my greatest common factor is an x to the 1. So I'll remove an x to the 1 as my first factor, and then in brackets, I need to divide both of the terms by that greatest common factor, x to the 1, that I took out. Now once again, maybe I'll write an intermediate line. I'll do this one more time, showing that the 8x squared and the 7x are both being divided by x. And when I simplify inside the brackets, 8x squared divided by x, remember the quotient rule for exponents. When dividing powers with the same base, you keep the base the same and subtract the exponents. 2 minus 1 is 1. So 8x squared divided by x is just 8x. Minus 7x divided by x is just going to be 7. The x's will cancel out. There we go, part B has been factored. Part C, if we look at the terms, the coefficients have a greatest common factor of 5. Right, the greatest common factor of 25 and 15 is 5. And both terms also have an x. We always take out the one with the smaller exponent, so I will common factor out an x to the power of 4. My greatest common factor between the two terms is 5x to the 4. What I need to do now is divide both of those terms, the 25x to the 6 and the 15x to the 4. I need to divide both of those terms by my greatest common factor, 5x to the 4. So I'll leave my first factor, and then inside the brackets, let me simplify. 25x to the 6 divided by 5x to the 4. Well, 25 over 5 is 5, and x to the 6 over x to the 4. When I subtract the exponents, it gives me x squared. Plus, my second term, 15x to the 4, being divided by my common factor of 5x to the 4. 15 over 5 is 3, and x to the 4 over x to the 4 is x to the 0, meaning the variable part of that term is gone. So that's it for part C. It's now in factored form. Part D, this is the first time where we have 3 terms. For all 3 terms, let's start by looking at the coefficients, 21, 28, and 7. The greatest common factor between those 3 numbers is 7, so I'm going to for sure common factor out a 7. Also notice for all 3 terms, they all have factors of x and they all have factors of y. Between the 3 terms, if we look at the x's, which x has the smallest exponent? It's the one in the third term, is just an x to the 1. We always take out the one with the smallest exponent, so I'll take out an x to the 1. If we look at the factors of y in each of the terms, the smallest exponent is 3, so I can common factor out a y cubed. So my greatest common factor is 7xy cubed. I now need to divide all 3 of those terms by my greatest common factor that I took out. So let me rewrite all 3 terms. And all 3 of those terms have to be divided by 7xy cubed. I'll rewrite my first factor. And now in brackets, let me simplify each of the terms. My first term, 21x to the 4y cubed divided by 7xy cubed. 21 over 7 is 3. X to the 4 over x to the 1 is x cubed. And y cubed over y cubed is y to the 0, so the y is gone. Minus 28 over 7 is 4. X squared over x is x. And y to the 5 over y to the 3 is y squared. Plus, my last term, 7xy cubed, is being divided by 7xy cubed. Something divided by itself is 1. There we have part D is now in factored form. Let's try 2 more where we're taking out a monomial as our greatest common factor. Notice in part E, all 3 terms, the coefficients are 4, 10, and 12. The greatest common factor between 4, 10, and 12 is 2. So I'm going to take out a 2. All 3 terms have factors of x. The one with the smallest exponent is x squared, so I'm going to take out an x squared as part of my greatest common factor. And they all have factors of y. The smallest exponent on y is 2, so I'll take out a y squared. My greatest common factor between all 3 terms is 2x squared y squared, so I'll have to divide all 3 terms by that greatest common factor. Let me write that. Let me rewrite my first factor, and then in brackets, let's do all of the division to simplify it. Let's divide the first term by the greatest common factor. 4 divided by 2 is 2. X squared over x squared, those cancel out, that's x to the 0. And y cubed over y squared is y to the 1. Plus, my second term, 10 over 2 is 5. X to the 4 over x squared is x squared. And y squared over y squared is y to the 0. The y's are gone. Minus 12 over 2 is 6. X cubed over x squared is x to the 1. And y squared over y squared is y to the 0. So the y's are gone. There's part E done. And let's move on to the last one for part 1 of this lesson. Look at all three terms. Let's start just with the coefficients of the three terms. 8, 6, and 4, the greatest common factor between those three numbers is 2. Now let's look at the variable part of each of the terms. Each of the terms have factors of x. I'll take out the one with the smallest exponent, which is x squared. And the last two terms have factors of y, but the first one does not. So I'm not going to be able to remove any factors of y as part of my greatest common factor. So all I can do is divide each of the three terms by 2x squared. Let's now simplify this. Leave my first factor. And then in the brackets, let's do all our divisions. 8x cubed over 2x squared will give me 4x. Minus the second term, 6 over 2 is 3. The x's cancel out, right? X squared over x squared is x to the 0, which is 1. I don't have to write a factor of 1. And there's still a y squared, so I'll leave that y squared. Plus 4 over 2 is 2. The x squareds cancel, and that factor of y remains. There we go, there's part 1 done. Notice for all 6 of those parts, we've rewritten each of the expressions in factored form. They're now all written as a product of two factors. In part 2, we're going to learn that you can factor out more than a monomial. If there's a binomial that's common between two terms, we can remove that as a common factor. If we look at example 2, notice once again, we have a sum of two expressions. The plus sign is separating our two expressions. If we look at the expressions to the left and right of the plus sign, notice they both have this factor of y plus 1. Since that y plus 1 is in common between both of the terms, what I can do is remove that factor of y plus 1 as my common factor. Make sure you keep it in brackets. And then what we have to do is divide each of the terms on either side of the plus sign by that factor of y plus 1 that we're taking out. Let's see what that looks like. I'll have to do 3x times y plus 1 plus 7 times y plus 1, all divided by that factor of y plus 1 we took out. I should have started with an equal sign, so I'll add that now. And maybe for this one, let me actually rewrite inside the bracket, separate it into both terms, showing that they're both being divided by y plus 1. So I'll leave that y plus 1 out front. Then in brackets, that first term, 3x times y plus 1, that's being divided by y plus 1. And the second term, 7 times y plus 1, is also being divided by y plus 1. I wrote it this way so that you can see that in both of those terms, we have a y plus 1 over a y plus 1. Those are all going to cancel. And then inside the square brackets, all that we're left with is 3x plus 7. So that's how you remove a binomial common factor. Let me show you how it works again. The minus sign is separating our two terms. We have a 2x times x minus 3 and a 5 times x minus 3. Both of those terms have an x minus 3 factor. So we can remove that as our common factor. And then in brackets, I need to divide both of those terms by what I took out. I have to divide the 2x times x minus 3 by x minus 3. And I have to divide the 5 times x minus 3 by x minus 3. When I do that, the x minus 3's will cancel in each of the terms, and my factored form looks like x minus 3 times 2x minus 5. If you look at our final expression compared to the original expression, you can probably see the connection without having to do this middle step where we rewrite it showing the division, but it's good to do that to understand what algebraically is actually happening when we're doing this method of factoring binomials. Oh, part C, we actually have a common trinomial. There are two terms separated by this minus sign. Both of the terms have a factor of x squared plus 2x plus 7. So what I can do is remove that, x squared plus 2x plus 7, as my common factor, and then divide both of the terms by that common factor. So I'll divide the 5x times x squared plus 2x plus 7. I'll divide that by my common factor, minus, I'll divide my second term, 4 times x squared plus 2x plus 7. Divide that by my common trinomial. In both of those terms, I can cancel those out, and I'm left with my final factored form answer of x squared plus 2x plus 7 times 5x minus 4. And there we have it. We've got each of those three into factored form, just a product of factors. We're going to finish off the lesson with one last thing. Some polynomials don't have a common factor, but can be factored by grouping. When factoring by grouping, what we do is we group pairs of terms together that do have a common factor. We remove a common factor from each group, and then we check to see is there a common binomial or trinomial, some type of expression between the two groups. So let's see how that works. Let's look at example 3. Part A, I've got 4 terms. Between the 4 terms, there's nothing in common that I could take out from all 4 terms. But if I were to consider the first 2 terms a group, and just to make you visualize the group, I'm going to put brackets around the first 2 terms. And then also I'm going to imagine the last 2 terms as being a group. So I'll put brackets around the last 2 terms. And notice when I'm doing this, putting them in groups, a very important thing to notice is that I left a plus sign between the 2 groups, right? When adding polynomials, we can just drop the brackets. So if I want to put up brackets, I have to make sure I have a plus sign showing it's those 2 polynomials being added. The reason why I did this, putting them into groups, is because if I were to just look at both groups separately and remove common factors from each group, I'm going to end up with a common binomial. Let me show you what I mean. In the first group, both terms have a factor of c. So I could remove a c as a factor from the first group. And to do that, I put a c out front and then divide both of the terms by the c that I took out, plus the group of the last 2 terms. Both terms have a factor of d. So I'll take out that factor of d and divide both of them by d, and let's see what we get. When I simplify inside the brackets for both of these, in the first set of brackets, the c's are going to cancel, and I'm left with a plus b. In the second set of brackets, the factors of d will cancel, and I'm left with, once again, a plus b. Notice the plus sign is separating my terms, and both terms have factors of a plus b. So what I can do now is remove that binomial common factor from both terms. I'll write the a plus b out front, and then in brackets, I need to divide both terms, the c times a plus b and the d times a plus b, by that factor of a plus b that I removed as a common factor out front. The a plus b's will cancel for both of those terms, and what I'm left with is a plus b times c plus d. For the last one, let's try and do this in fewer steps. For part B, once again I have 4 terms, and notice all 4 terms, the greatest common factor between all 4 terms is just 1. There's nothing I can take out. But if I were to factor by grouping, maybe if I take a common factor from the first 2 terms and from the last 2 terms, I'll end up with a common binomial that will allow me to get it into factored form. I'll try and do fewer steps this time. I'm not going to draw brackets around the groups. I'm just going to look at the first 2 terms, the 9x squared and 15x, and see what is the greatest common factor between just those 2 terms. Between 9 and 15, the greatest common factor is 3, and they both have an x. Take out the one with the smaller exponent, which is an x to the 1. I now need to divide both of those first 2 terms by 3x. 9x squared divided by 3x is 3x, and 15x divided by 3x is 5. The last 2 terms, 3x and 5, the greatest common factor is just 1, but that's actually fine. Normally we don't write factors of 1, but for this question I'm actually going to write the factor of 1. And then if I divide each of those terms by the factor of 1 that I'm taking out, it doesn't change anything. It's still 3x plus 5. Notice I have a plus sign separating my two terms, and both of the terms have a binomial 3x plus 5. So they have a common binomial. We can factor out that common binomial, put it out front, and then divide each of the terms by the 3x plus 5. When I divide my first term by 3x plus 5, the 3x plus 5s will cancel. I'll be left with 3x. When I divide my second term by 3x plus 5, the 3x plus 5 cancels, and I'm just left with 1. And there we have it. We're in factored form. Once again, if you wanted to check your answers to any of these, you could expand it back out. You could do FOIL, multiply this out, and it should take you back to the original expression. So I hope by the end of this lesson you now have a general idea about what factoring is, and you know how to do common factoring of a monomial and also of a binomial. Make sure you try out the practice questions and go to jensenmath.ca for all supporting materials.